from that, right? Were those real experiments? They weren't even actually true experiments. Now, it was an experiment, but what it is you're going to see is a type of pre-experimental design. There was no control group. There was no random assignments. So we just looked at what happened to people under certain circumstances, right? So that's called a pre-experiment design. It's an experiment, but it's the worst possible type of experiment in the sense of being able to prove what's true or not. So experiments give us the most ability to prove what's true and what's not, but it only happens when we have the things you see up here. So experiments, we're testing hypotheses like the conformity. People will conform and say things that aren't true just to fit in. But in order for it to be a true experiment, you need to know this for your quiz, you need to have random assignment to experimental and control groups. So you need to have some people that are getting the intervention, like we saw there, of the sugar water, and some people that are not getting the intervention. So someone in the room who didn't drink anything, but is exposed to the same circumstances. That would be a control. And who gets to drink the sugar water and who doesn't drink anything, that needs to be randomly decided so that the people that are getting the intervention are theoretically the same as the people that are not getting intervention, and they're comparable. Now, it really only works if you have a relatively large group, like more than 10 or 15 people. And in that case, his experiments are usually very small, just a few people, 5 people or so. But in order for it to be a true experiment, you need random assignment to experimental group and a control group. So you either get the intervention or you don't, but something is the same across both groups. And you're giving some kind of intervention to the group that's in the experiment. And you need a post-test. A post-test means you're doing a survey with them later where you're asking them questions that measure what it is you are looking for. So he does it informally when he debriefs them, but typically we do a more formal post-test, which is a survey with very specific questions and scales that we're looking at. Now, I want you to notice there is no pre-test here, right? We don't need to ask them anything before for it to be a true experiment. So the 3 key features you need to notice for your quiz: random assignment to experimental and control. You are providing an intervention of some sort to the experimental group. And there's a post-test, basically an evaluation at the end. Now, there is a way under this what's called the classic experiment design where you have at the bottom here a pre-test before and a post-test after. And in the classic experimental design, like if you're testing an intervention for depression, you evaluate how depressed they are at the beginning. Half the people get the intervention, half don't. And then you do a post-test at the end to see their depression. So you're measuring the same thing before and after in a classic experiment. So classic has a pre-test and a post-test, but a true experiment only needs to have a post-test at the end, with the idea being the comparison is the control group versus the intervention group. So when we're doing a classic experiment, we start off with finding a group of people to participate, and typically it's a purposive sample of some sort. You're recruiting people, like the Stanford Prison Experiment. They were students on spring break, but you need some way to find participants. And then you need some strategy to say whether they're in the experiment getting the intervention or not. Typically in a classic experiment, you're going to do a pre-test of them, evaluating them for the social factors that you think are important or might be affected by your intervention. Do the intervention and then a post-test later to see whether or not you got the effect, or not your pre-test and post-test are different. So this next slide actually has one of the most important things for your quiz and your final exam. They're both going to ask you about the Solomon 4-group design. The Solomon 4-group design is a fascinating idea, looking at every possible way that we can combine people that are in the control group and the intervention group. So in the Solomon four-group design, you have a pre-test. So you have four groups. One group has a pre-test, intervention, and a post-test. The X stands for intervention. So the O is observation 1 pre-test, the X is the intervention, and O2 is the post-test evaluation. So for one group, you have a pre-test, intervention, post-test. For the second group, it's a control group that you have a pre-test and a post-test for. And this way, you're just measuring whether or not knowing the pre-test, what the pre-test was about when you do the post-test, whether or not it was the test that affected the results and not the intervention, right? And then the third group has an intervention and a post-test, which is like a classic, like the true experimental design, where you do intervention and post-test. And then the fourth group, just a post-test. So the idea is everyone, all four groups that were randomly assigned, you have a final observation at the same time period. So say we're exploring depression, and we have four groups, and we know what the depression level of the four groups is at the end, and it should be, if the intervention had no impact, then it would be the same for all these groups, right? If the intervention had an impact, then we would find that groups 1 and 3 were different, that they had the different results because the intervention changed the depression score. If we found, in fact, that group 1 and 2 had the same results, then what would be is the intervention didn't have the effect, but the pretest is what changed people's scores. So just asking people the depression test once and then asking them the second time, they might change their answers the second time because you might be just finding either random variation or the idea that they want to help you and they want to give you higher scores. So with the Solomon four-group design, we have 4 randomly assigned groups, and the difference is who gets the intervention and the pre-test and post-test. So every possible combination there, and it allows us to eliminate the possibility of whether it was a pre-test that changed the results or the intervention that changed the results. So when there's the idea of the testing effect, where what we're measuring changes simply because they've already been exposed to it. So the Solomon four-group design allows us to prove whether or not that was the case or not. The post-test only control group design is part of the true experiment in the middle there. And so the true experiment doesn't need a pretest because you're assuming that the random assignment to the 2 groups was equivalent, and therefore it was just the intervention. Does that make sense? We do the quiz preparation. So this next word is important that you know, is quasi. Quasi means sort of. So a quasi-experimental design is sort of an experiment, but in the case, this case, you don't have random assignments. So in a quasi-experimental design, you have intervention and a control group, but they weren't randomly assigned. So say we're testing out a textbook in 2 different classes. That's a quasi-experimental design because one class is one book, the other class is a different book, but it wasn't randomly assigned to students. It was by class, and the classes might be different. So without random assignment, we have a comparison group, but it might not be equivalent. So that's quasi-experimental. It's a true experiment without random assignment. Versus on the right, the pre-experimental design, you have no comparison group, and that's what we saw in the video. There's no comparison group. You're trying out an intervention on people to see if it worked. If it worked, if it had that impact, you can say, oh, the intervention had impact. And maybe, but you don't know whether or not it was the intervention or just the thought of it. I'll give you an interesting example. There was, with surgeries, there's something called sham surgery, where it's a pretend surgery. So when they want to test out, like the ACL tears on ankles, there were some studies found that just thinking you had the ACL surgery was enough to get the same results as the people that had the surgery. and the ACL will actually heal itself under certain circumstances. So what they do in these sham surgeries is they literally make an actual cut, and but they don't do the surgery. So that way you think you had the surgery, but you don't, in fact. So this kind of pre-experimental design without a comparison group, you can just test a pretend intervention and find that might be good enough. It's just the thought that you had it, and the ankle can develop under many circumstances. So there's unique circumstances in every case. All right, back to the idea of quasi, the sort of experiment. So with quasi-experimental design, it's like the classical experimental design, only without random assignment. And there are some situations where there's like a natural experiment, and we could have looked at how different states responded to COVID as a natural experiment to see whether or not the interventions that the states did had any impact at all. And at first, we thought there was going to be a big impact based on masking policies across states, and then we found in the end it really wasn't as big an impact as we had thought. So, so natural experiments happen when comparable groups arise in the real world. There are lots of studies looking at different countries and how things spread in different countries, things like that. So sometimes we just make observations in the real world as a natural experiment, and that's sometimes good enough for us to have a sense of what works and what doesn't work. Sometimes in quasi-experimental designs, we can purposely match people. So you do an intervention on 10 people, and then you find 10 different people that are similar in some way, and use them as a comparison. So you match people based on age and race and social class or something, and you assume that those people should be similar in some ways. So that's another way to do it. It's not perfect, but it allows us to have some power. So that's quasi-experimental. Non-equivalent comparisons or purposeful matching. So basically, quasi-experimental, it's not random. Anything that's not random. With pre-experimental design, we just have one group with, it could be a pre and post test where you do before and after without a comparison, or it could be one group without a pre-test like we saw in the videos, or it could be a static group where you have a comparison group, but the comparison group has no pre-test. But basically, if there's no random assignments and little effort to create a comparison group, then it's pre-experimental design. That said, these quasi and pre-experimental designs, actually most experiments are quasi or pre-experimental because it's easier. And depending on the topic, you might not be able to do a pre-test or there is no good control group available for that topic. So it limits what conclusions we can draw, but it's sometimes the best we can do. So in order to prove causation, in order to prove that the intervention worked, we need to prove covariation. In other words, the factors change in the same way. So more time in the intervention, less negative behavior. So say a smoking intervention, we want to prove that people that participate more time in the intervention have lower rates of smoking. That's an example of a covariation. Factors changing in a way. Plausibility means it makes sense. Temporality means the time order works and that the before and after is obvious. So experiments by nature are semi-longitudinal in the sense that you have measures before and after, sometimes multiple measures. And non-spuriousness. In other words, it isn't something else that's causing the problem. It's unrelated. So you need to eliminate other possible causes, non-spuriousness. So with experiments, we have very strong internal validity, the ability to prove cause and effect, and to prove that the variation in the dependent variable was caused by the experiment itself. So that's strong, and so this is how we test interventions and programs through experiments. However, experiments are poor when it comes to external validity in our ability to match experimental conclusions to larger populations, because we only studied a handful of people. So this is the reason why drugs usually aren't perfect. They work for some percentage of the population, but not everyone, because they're tested in experiments that are only a small group of the population, and they can't be tested at the larger population as easily. So external validity is often low, but internal validity is high. The idea of replication is important, so other people should be able to replicate that same experiment and prove that they can find the same result. If they can't, then there's something wrong with the conclusions. So experiments are high in internal validity, low in external validity, and should be able to be replicated. If they can't be replicated, then we can doubt the results. So internal validity is our ability to make conclusions that the intervention worked. And there are possible reasons why we might not be able to link cause and effect so well. There can be external events like September 11th or the COVID pandemic or other big news that happened locally that affected everyone in some way. So you might find that just before a holiday, people's mood is better, and it gets worse right after the holiday. So there could be some external event affecting the results. The green box about how people respond to being part of a study. The people that volunteer participate are different than people who don't. So you can't draw conclusions that people who don't participate are the same as people who do. And of course, the people conducting the study have a benefit in proving that their intervention works, and so they might design the study to show that it works even though it isn't as effective as they think it is. And of course, devil's always the detail of how it's administered and how the participants relate to the clients and such. So lots of reasons why the experiment might seem to make sense, but some external reason might cause a problem. And here we have other problems that can happen to cause experiments to not give us the results we want. You have selection bias, so not collecting data from a diverse population, finding it a very specific group. Therefore, you might find a group that's predisposed to your intervention being effective or predisposed to it being ineffective. Mortality usually means death, and in aging studies, death is part of it. But typically in experiments, mortality refers to people dropping out of the study. So people give up, it's as if they died, but they didn't really. So mortality in this case is just referring to people no longer participating, giving up partway through. Reactivity is how involved participants are in the study. Some people are really reactive, some people aren't. And sometimes it's acting. It may not be as extreme as it seemed to observers. Compensatory rivalry. If you have multiple subjects in a study, they know each other, they might be trying to outdo each other in their responsiveness to the study. So any kind of rivalry between participants could affect the results. Any kind of a Mr. Beast challenge videos, you're finding a lot of compensatory rivalry. Resentful demoralization. That's like the Stanford prison experiment, where people are not treated right. They may turn out angry and not give you the same results. Sometimes the placebo group that didn't get the intervention is still able to get some of the benefits of it because they know people in the study getting the intervention, and so you get this idea of diffusion of treatment where the concepts in the intervention spread beyond just the intervention group, and everybody starts to know about it. Placebo effect is this idea that just feeling like you're taking a medicine makes you feel different, and that effect is real. About 20% of the time, just thinking you had a good medicine can have a positive effect, or thinking you were in an intervention should help has an effect, even if the intervention itself didn't do anything. Treatment fidelity is this idea that whether or not we're following the protocols correctly. Testing is basically people's awareness of what we're testing and the fact that they're aware that you're measuring depression and anxiety or whatever it is makes them hyper-aware and might affect the results. The instrumentation, the type of questions you're asking and how you're asking the questions can affect the results. Any history they have with that topic can affect the results. And maturation, how people just naturally change over time. Particularly long-lasting studies, some of what you're getting isn't the intervention, but just general maturation happens as people mature all the time. So let's review for the fourth quiz. And so for the fourth quiz, you need to remember that true experiments require random assignment. Random assignment is really the key to any true experiment. You need to know that the control group does not get a treatment. So they need to participate in some way, but they don't get the treatment. It might be as simple as just doing the post-test. And you need to remember that all true experiments do require a post-test. And you need to know that the post-test is measuring the dependent variable. So whatever it is that we care about in the intervention, that is what we're measuring in the post-test, the dependent variable. The idea is ideally we're looking at how the intervention group varies in the dependent variable versus the control group. And true experiments are designed to maximize internal validity and our ability to link cause and effect. That's the internal validity. And remember I mentioned mortality is the word we use when people drop out of a study. So mortality is the dropout. Dropout, it's a mortality. And remember that anytime that in a true experiment, the intervention gets the intervention group and the control group doesn't. One of the quasi-experimental designs is the idea of a wait list, and that some of your participants don't get it initially. So basically half of them get it right away, and half don't, and that's the half that don't are your control group. But if you think the intervention is good and helpful, then you can put people on a wait list, and so the control group gets it later. And so that's a form of quasi-experimental design, where your control group gets put on a wait list, and so they get it later. So at least they have the option of getting it later. Like with the COVID vaccines, that's how they did it, where they gave half the people a placebo to test, but because it was shown to be effective, then the control group got it later. So it was actually a quasi-experimental design. If the problem just resolves itself over time, not result of the intervention, that's called maturation. When we're thinking about true experiment designs, know that they are the most rigorous of the designs. So true experiments are the most rigorous experimental design, and that is our goal when we're designing medical studies or large-scale social studies. And finally, remember the Solomon four-group design, and that is the design that reduces the chance for testing and treatment effects. All right, we covered a lot today. 2 different topics, 2 different quizzes, but I am highly confident you guys can do well on this. If you have any problem with any of the quiz questions, let me know, and I'll go back and fix it for you. So thank you guys so much. Done a lot. We'll see you guys on Monday.